So hello everyone. Today we are going to take mechanical mates. In mechanical mates we are going to cover rack and pinion mate, hinge mate and cam mate. So to start with rack and pinion mate, I am going to refer design library here. In design library we are going to take toolbox option, and from toolbox we are directly going to call the required parts for rack and pinion. That will be rack gear and pinion gear, that is spur gear. So to start with, I'll say add in now. Standard, I am going to select here ISO, power transmission, gears. So in gears, first I'll call rack gear here. Rack means a straight profile gear in which we have to mention the module. Module is overall size of teeth. It doesn't have any unit here. So the module I am going to take here is 3. Next parameter we are going to see here is face width. It is showing 15 mm here. So this is the face width here, the width of the object. Next important parameter here is length of the rack, that is 300 mm. Suppose if I want to change the length of the rack, then we'll select this part, say right click, edit toolbox components, and in rack we'll provide the length here as 550 mm. We have to remember that we have taken module value here as 3. Say it OK. Next part we are going to call here is spur gear, which is going to run with reference to rack and pinion arrangement on this rack gear. So we'll call the part here from design library. Say spur gear here again. In previous videos we have seen gear mate, and we have seen what are the parameters for this spur gear there. So you can refer that video also, the previous video in playlist. So for spur gear also we will continue with the same module, that is module 3. Number of teeth here it is showing as 40. I'll change this number of teeth and say 25. So the number of teeth here is showing 25. Hub style, that is type A only. I'll keep this hub style type A. If you want to change the hub style, then you can go for type B. Hub means one extrusion will appear here. So hubs are used to maintain the alignment of the shaft when the gears are rotating at high speeds. If you want to change the diameter of hub, you can change the diameters also here. You can control the style of hub. If you want both sides, then you can go for the both side option here. Suppose I want to change the length of the hub. I'll say it 80 mm. So this hub length is 80 mm now. Nominal shaft diameter here it is showing as 15 mm. You can see here nominal shaft diameter is 15 mm. I will remove the hub here. I have taken that hub only to show you what is hub and how to customize the hub. We don't require hub here. I'll say it OK. So we have configured the gear also here, per gear. Now the first mate we are going to apply here is, coincide mate between front face of the gear and the front face of the rack gear. We'll flip the direction. Both the faces are being coincided here, but they are at opposite directions. So if you want to coincide them in same direction, then we'll flip the dimension of the alignment. Say it OK. Now you can see both front faces of the gears are coplanar now. So after making coincide and coplanar the front faces of the gears, we'll arrange this gear, take this gear at upward side, keep the rack normal here, let that gears be engaged here. Next, we need to show the pitch circles here. So we'll go in spur gear option in model tree. So we'll select the spur gear part in model tree, and you can see the tooth cut option here. And in tooth cut, you have to show the sketch here. By expanding this arrow, you will get this tooth cut sketch. You just need to show it. Then the pitch circles for that gear will be shown here. So we will require to show these pitch circles here. It will also highlight the center of the pitch circles here. So after showing the pitch circles, we'll go in mate option. We don't need to select any mate directly. We have to just give the selections between which we want to apply the mates. The selections will be center point of the pitch circles we have shown here in sketch. So I'll select the center, and the second selection will be edge of the rack. Suppose if this gear directly comes down here, it may not apply the rack and pinion mate here. That time you just need to do one thing, that is to close the software completely and again restart the Solidworks and then apply for the same steps. So I am going to do that only. So we have restarted the Solidworks and completed the back steps here. Again we are going to start with the mate, and what we were going to do here is select the center point and the rack's bottom edge here, and whatever distance it is showing here, we just need to select the icon of distance and apply whatever the distance is coming between this point and line here. If this gear again comes down, we have to repeat the same process, that is to close the software and restart the software again and then repeat the mate. I'll say it okay here. So here we have applied the distance mate. We have not counted any distance. We just clicked on this point and edge. Whatever distance came, we just applied by saying it okay. And now we are going to go for mechanical mates. And in mechanical mates, we are going to go for rack and pinion. Select the rack here as this linear edge of the rack gear and pinion here as the pitch circle, outer pitch circle of the spur gear. We have given the selections of the references required for the rack and pinion mate. I'll say it okay. And now if we drag this part here, you can see this gear is following the teeth of the rack and traveling in between the rack here. Suppose if I want these two parts to be moving in relative motion with each other, then I'll provide one more part here. I'll provide one shaft. You can see here the diameter is showing here at the bottom. So what we'll do is we'll make one part or shaft here with diameter 15 mm. So I have already made this part here. We have browsed the part and we are going to assemble this part in nominal shaft diameter. For that we are going to select mate. We will say concentric mate between shaft and circular hole here. Say it okay. To align the shaft between the gear at the centers, we'll go for advanced mates and select width mate here. In width selection, I'll select both the faces, both the side faces, in the gears both the side faces. This part or shaft is been centered align here. Say it okay. And now as we have called this rack gear as the first part, this part was fixed. You can see here rack gear. The F sign is showing here, highlighting that this rack was fixed. So I will float this rack first and I will make fix this shaft only here. It is compulsory to make one of the part fixed. Then only we'll get the relative motion between the spur gear and rack. So I'll fix this shaft. And now if I drag this rack here, you can see gear is also been dragged. But the motion of the rack gear, it is becoming inclined. So to solve that, we'll go for parallel mate. So for the selections, I'll apply the mate. And while applying the mate, we'll open this pin part and take the top plane of the pin parallel with the bottom face of the rack gear. Now you can see parallel mate has been applied. Say it okay. Again okay. Now this rack gear is also stable. You can drag and see rack and pinion arrangement and motion has been applied here. I'll hide these sketches here. So in rack and pinion arrangement, one part will rotate and the other part relatively will reciprocate with the first part. So that is rack and pinion arrangement. The example you can have here is the steering wheel of the four-wheeler. You can also refer the rack and pinion example as we have seen the glue sticks here. As you rotate the glue stick from the bottom, that tube will come outside in linear motion. So that circular motion at the bottom will be converted to linear motion. So in this example, we can call that relative motion as rack and pinion mechanism. Steering wheel of four-wheeler is also one of the example. As you rotate the steering wheel, the axial wheel of the steering wheel will reciprocate there. So that is also one of the examples of rack and pinion only. So the next mate we are going to see here is cam mate. For that I'll browse the parts. I've made some parts for cam mates. So first I'll browse the cam base here. I've made the circular base. For different machines this cam base may differ in shape and size. I have made it circular one. As it is the first part of assembly, I'll right click this part, say float, and then we will apply the coincident mate between the first part, origin of the assembly, and the assembly's origin. This will make all the planes at the center alignment. You can see all the three planes of assembly in first part are now been aligned here. Then we will go for the next part. I'll insert the next part here. We will consider it as cam piston rod. Say it open. And now we will make these parts concentric. Say OK. We will keep this motion in continuity. Next part we are going to call here is cam body. Say open. Will coincide the front flat face of the cam body with the flat face of the cam piston rod. Both the faces are coincided, but the alignment is opposite. So I'll flip the mate alignment here. Say it OK. And now both these faces are coplanar with each other. You can see here, both the faces are coplanar now. Next part we are going to call here is cam shaft. Before that, we will revise once again what mates we have taken here. So the first mate was coincide mate. By coincide, assemblies origin with the first part origin. Second mate was this concentric mate. You can see parts are highlighting the required surfaces selected for the mate. Then the third mate we have taken here as coincide mate between these two faces. Next part we are going to call here is cam shaft. Select the cam shaft, say open. Again mate. Make this cam shaft concentric with the cam bodies hole here. Say it OK. Next we will apply the width mate for the center alignment of the shaft. Select the mate option. Go for advanced mates width. Select the required faces of shaft. Same for the body here. And this shaft is center aligned now. Say it OK. Now you can see this shaft is moving horizontally. So I want to make this shaft align with the cam piston rod so that it should not move horizontally here. For that, I'll make coincide the center plane of the assembly with the center plane of the shaft. We will go for mates. We will select the front plane of the assembly first and same orientation plane for the shaft. That will be right plane here. So both these planes are coincide now, you can see here. So if I coincide this shaft plane with the assembly's plane, so this shaft will stop moving side by side here. Say it OK. And now if I drag the shaft at the sides, you can see it will not move as the center planes of both the assembly and shaft part are being coincided there. Next, we are not having any standard height for the cam shaft to be placed. So I'll randomly place the shaft here. Say right click on the shaft and I'll fix the shaft here. As the shaft is fixed now, it will not move vertically also now. It will not move vertically also now. You can see the cam movement around the shaft. All the parts are moving in condition except the cam base and cam shaft. Now we will again see the history of the mates we have given here. First mate was assembly's origin with first part origin. Second was concentric mate. Third was this coincide mate. You can see the faces highlighted there. Fourth was the concentric mate between cam shaft and cam body. Fifth was the width mate. And now the next mate we are going to take here is cam mate, which comes under mechanical mates category. Select the mate option. Go for mechanical mates and select the cam mate here. In cam mate, first we have to select the cam path here. I'll select this as a cam path, the side faces of the cam body. And then we'll go for cam follower. For that we will select this round portion of cam piston rod. Say it OK here. And now as I rotate this part, so as we rotate here, you can see this cam piston rod is tangent with the cam path. So it will follow the cam path here. As we rotate the cam body, you can see the reciprocating motion there. So here the cam mate has been applied. So this was cam mate for you. So the next mate we are going to see here is hinge mate. So to start with hinge mate, I'll browse the parts here. I've already made some parts for hinge mates. I'll select hinge 1. Now this is the part hinge 1, which is having 3 knobs here. I'll call the second part also. The mating part having 2 knobs here. Now both of them are lying at the similar sides. We'll rotate the second part. Here you are having rotate component option. by which you can rotate the part orientation without applying mates. So I'll select the rotate component option here and I'll rotate this part orientation. Say it OK. And now we will go for hinge mate. For that we'll select the mate option and directly go for mechanical mates and hinge mate. So hinge mate is nothing but combination of two mates, that is coincide mate and concentric mate. Both these mate can be applied at one platform here, that is called as hinge mate. It comes under mechanical category only. So for concentric selections, I'll select the circular faces here. And for coincide selections, I'll select the alternate faces which are going to be engaged as these hinges will be put together. So I'll select this face here. And the other face, I'll select this face of the first knob. Say it OK. And now you can see hinge mate has been applied and both this part are engaged together with hinge mate. But we can also see this part is rotating here completely 360 degrees. So we'll apply the limit angle mate there. From advanced mates, I select the mate option, go for advanced mates, select the limit angle mate. So the maximum angle I am going to select here is 180 degrees and minimum angle will take it as 0 degrees. So the selection of reference faces I am going to give here is internal faces. You can flip the part orientation as well as you can flip the part dimensions also. You can see here, say it OK. And now as you rotate this part, it will go for the maximum angle here as 180 and minimum 0. Now it will not completely rotate there as limit angle mate has been applied. So this was hinge mate here. So these were all the mechanical mates. In next lecture we are going to continue with some more commands related to assembly. Till now we have completed all the mates. So to learn all the mates, please go through the SolidWorks playlist given there. Till then, thank you.